Section 9.3, Adding and Subtracting Rational Expressions. Example 1, 5x over 12 plus x over 12. When adding or subtracting fractions, there must be a common denominator. 5x over 12 plus 1x over 12. Add the numerators, the denominator stays the same. 6x over 12. Reduce the fraction, x over 2. Example 2. There is already a common denominator, so we just need to add the numerators. X plus 3 divided by x squared minus 9. Factor the denominator. X plus 3 divided by x plus 3 times x minus 3. Reduce the fraction. X plus 3 divided by x plus 3 reduces to 1. 1 over x minus 3. Example 3. 2x squared minus 2x squared divided by x squared plus 7x minus 8 minus x minus 1 divided by x squared plus 7x minus 8. There is already a common denominator. Subtract the numerators. Watch the signs. 2x squared minus x plus 1 over x squared plus 7x minus 8. Example 4. 1 over 6a plus 4 over 9b minus 5 over 2a. We must find a common denominator. 6, 2, and 9 all divide evenly into 18. The variable part of the denominator will be a, b. We're going to multiply each fraction by something different. The first fraction we're multiplying by 3b over 3b. The second fraction we have to multiply by 2a over 2a. And the third fraction we have to multiply by 9b over 9b. Multiplying 3b over 18ab plus 8a over 18ab minus 45b over 18ab. Only combine like terms in the numerator. 8a minus 42b over 18ab. Reduce each coefficient by 2. 4a minus 21b over 9ab. Example 5. A minus 1 over a squared b minus a minus 2 over ab. We must find a common denominator, and we'll multiply the second fraction by a over a. First fraction stays the same, a minus 1 over a squared b minus a minus 2 over ab times a over a. A minus 1 minus a times a minus 2 over a squared b. Careful with your signs and your numerator. A minus 1 minus a squared plus 2a over a squared b. It's negative a squared plus 3a minus 1 over a squared b. Example 6. 7 over x plus 2 plus 2. Find a common denominator. We need to make the second term a fraction. And we're going to multiply the second fraction, 2 over 1, by x plus 2 over x plus 2. 7 over x plus 2 plus 2 over 1 times x plus 2 over x plus 2. 7 over x plus 2 plus 2x plus 4 over x plus 2. Adding your numerators, it's 2x plus 11 over x plus 2. Example 7, a minus 1 over a minus 2 minus 3a plus 1 over a squared plus 3a minus 10. Start by factoring the denominator on the right. It's a minus 1 over a minus 2 minus 3a plus 1 over a plus 5 times a minus 2. We can see that both denominators have a factor of a minus 2, so our fraction on the left we need to multiply by a plus 5 over a plus 5. It's a minus 1 times a plus 5 minus 3a plus 1 over a plus 5 times a minus 2. I've got an error. A squared plus 5a minus 1a minus 5 minus 3a minus 1 minus 10 minus 1. I have the answer correct. A squared plus a minus 6 over a plus 5 times a minus 2. Now factoring the numerator, a plus 3 times a minus 2 over a plus 5 times a minus 2. That's a plus 3 over a plus 5. Example 8, 2x squared minus, 2x squared over x squared minus x minus 12 minus 7x plus 4 over x squared minus x minus 12. Denominators are equal, so subtract the numerators. 2x squared minus 7x plus 4 over x squared minus x minus 12. We're going to factor everything. 2x squared plus 1x minus 8x minus 4 over x minus 4 times x plus 3. We had to ask ourselves what multiplies to 8 and adds to negative 7. We can now factor by grouping in the numerator. X times 2x plus 1 minus 4 times 2x plus 1 over x minus 4x plus 3. X minus 4 times 2x plus 1 over x minus 4 times x plus 3 reduces to 2x plus 1 over x plus 3. Example 9, we have an equation to solve with fractions. 5 over x plus 2 equals 7 plus 8 over x plus 2. Clear the fractions from the equation by multiplying each term by x plus 2 over 1. Simplifying, we get 5 equals 7x plus 14 plus 8. No fractions. Combining like terms, 5 equals 7x plus 22. Subtract 22 from both sides. 7x equals negative 17. Divide by 7. X equals negative 17 over 7. Example 10, 5 over x minus x over 3 equals 9 over x. Again, we want to clear the fractions, and we're going to multiply each term by 3x over 1. Simplify carefully, and we get the equation 15 minus x squared equals 27. Subtract 15 from both sides. Negative x squared equals 12. Divide by negative 1 on both sides, and we have x squared equals negative 12. Any number we square will never equal a negative number. The answer is no solution. That's section 9.3, adding and subtracting rational numbers.